The master's exam proctored through Thomson Prometric is generally considered challenging. This is due to several factors. Firstly, the exam offers comprehensive coverage. It covers a wide range of electrical theory and applications. This includes advanced concepts and calculations. Secondly, there is a time constraint. The exam is typically timed, and you only have a limited amount of time. This time is to complete multiple choice questions and perform calculations. Thirdly, there is the depth of knowledge required. To pass the exam, candidates must demonstrate a deep understanding of electrical principles. They also need to know their practical application. The number of years of experience in the trade is not a direct predictor of success on the master's exam. However, most candidates who pass the exam have significant experience in the electrical field. This often includes 4 to 8 years of experience as a licensed journeyman electrician. Candidates with experience in supervising and managing electrical work may also have an advantage. Individuals with a background in teaching or instructing electrical subjects may also perform well on the exam. To increase your chances of success on the master's exam, consider the following tips. Firstly, study thoroughly. Cover all the material outlined in the exam prospectus. Secondly, practice calculations. Master the ability to perform electrical calculations quickly and accurately. Thirdly, seek support. Consider taking a prep course or working with an experienced mentor. Fourthly, manage your time. Familiarize yourself with the exam format and practice completing questions within the time limit. The exam is demanding, so maintain concentration throughout. Remember that the master's exam is a challenging but achievable goal. With proper preparation and dedication, you can increase your chances of success. Electrical theory encompasses a broad range of concepts that are crucial for understanding how electrical systems function. This includes fundamental principles such as Ohm's law, which states that voltage equals current times resistance, often written as volts equals amps times ohms. Understanding this relationship is essential for analyzing circuits and troubleshooting electrical problems. Another core concept is Kirchhoff's laws, which provide a framework for analyzing complex circuits. Kirchhoff's current law states that the total current entering a junction must equal the total current leaving it. Kirchhoff's voltage law states that the sum of the voltages around any closed loop in a circuit must equal 0. These laws are invaluable for determining current and voltage values in various parts of a circuit. Alternating current, or AC, and direct current, or DC, are two primary types of electrical current. DC is characterized by a constant flow of current in one direction, while AC involves a current that periodically reverses direction. The frequency of AC is measured in Hertz, which indicates the number of cycles per second. In the United States, the standard AC frequency is 60 Hz. Understanding the characteristics of both AC and DC is crucial for designing and maintaining electrical systems. Impedance is another essential concept in electrical theory. It is the measure of opposition to the flow of alternating current in a circuit. Impedance includes resistance, which opposes current flow in both AC and DC circuits, as well as reactance, which opposes current flow only in AC circuits. Reactance is further divided into inductive reactance caused by inductors and capacitive reactance caused by capacitors. The total impedance in a circuit is a complex quantity that takes into account the combined effects of resistance and reactance. Power calculations are also fundamental to electrical theory. Electrical power is the rate at which electrical energy is transferred in a circuit. It is typically measured in watts, and it can be calculated using various formulas. In DC circuits, power equals voltage times current, or watts equals volts times amps. In AC circuits, power calculations become more complex due to the presence of reactive components. In these circuits, we distinguish between real power, which is the power actually consumed by the circuit, and reactive power, which is the power that oscillates between the source and the reactive components. The total power, or apparent power, is the vector sum of real and reactive power. Understanding these power relationships is essential for designing efficient and reliable electrical systems. Electrical applications cover a wide range of practical uses of electrical theory. Wiring methods are a critical aspect of electrical applications. They involve the techniques and materials used to safely and effectively route electrical conductors. The National Electrical Code, or NEC, provides detailed guidelines for wiring methods to ensure safety and prevent electrical hazards. Common wiring methods include conduit systems, cable trays, and direct burial cables. Each method has its own advantages and disadvantages depending on the specific application. Grounding is another essential aspect of electrical applications. Grounding provides a low impedance path for fault currents to return to the source, which helps to protect people and equipment from electrical shock. The NEC mandates specific grounding requirements to ensure electrical safety. Grounding systems typically include grounding electrodes such as ground rods or metal water pipes, as well as grounding conductors that connect to equipment and enclosures. Overcurrent protection is a critical safety feature in electrical systems. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. These devices protect against overloads and short circuits, which can cause fires and other hazards. The NEC specifies the types and sizes of overcurrent protective devices that must be used in various applications. Motor control is another important area of electrical applications. Electric motors are widely used in industrial, commercial, and residential settings to power a variety of equipment. Motor control systems are used to start, stop, and control the speed and torque of electric motors. These systems can range from simple manual starters to complex electronic drives. The NEC provides guidelines for the installation and protection of motor circuits. Lighting is a common application of electrical theory. Lighting systems are used to provide illumination in a variety of settings. Lighting design involves selecting the appropriate type of light source, such as incandescent, fluorescent, or light-emitting diode, LED, as well as determining the optimal placement and control of lighting fixtures. The NEC provides guidelines for the installation and wiring of lighting circuits. The electrical calculations are a fundamental skill for electricians and electrical engineers. These calculations are used to determine the proper size of conductors, overcurrent protective devices, and other electrical components. Ohm's law is a basic tool for calculating voltage, current, and resistance in circuits. Power calculations are used to determine the amount of power consumed by electrical equipment. Voltage drop calculations are used to ensure that voltage levels at the load are within acceptable limits. Short circuit calculations are used to determine the magnitude of fault currents, which are used to select appropriate overcurrent protective devices. The NEC provides tables and guidelines for performing electrical calculations. Advanced concepts in electrical theory include topics such as three-phase power systems, transformers, and power electronics. Three-phase power systems are widely used in industrial and commercial settings because they provide a more efficient and reliable way to distribute electrical power. Transformers are used to step up or step down voltage levels to match the requirements of different equipment. Power electronics involves the use of semiconductor devices to control and convert electrical power. This includes devices such as diodes, transistors, and thyristors. Advanced electrical calculations include topics such as power factor correction, harmonic analysis, and transient analysis. Power factor correction is used to improve the efficiency of AC power systems by reducing the amount of reactive power. Harmonic analysis is used to identify and mitigate the effects of harmonic currents, which can cause equipment overheating and other problems. Transient analysis is used to study the behavior of electrical systems under transient conditions such as switching operations and lightning strikes. Advanced electrical applications include topics such as renewable energy systems, smart grids, and electric vehicles. Renewable energy systems such as solar and wind power are becoming increasingly important as we transition to a more sustainable energy future. Smart grids are advanced electrical grids that use digital technologies to improve the efficiency and reliability of power delivery. Electric vehicles are becoming increasingly popular as a way to reduce greenhouse gas emissions. The NEC provides guidelines for the installation and operation of these advanced electrical systems. The NEC plays a crucial role in ensuring the safety of electrical installations. It is a comprehensive set of standards and guidelines that cover all aspects of electrical wiring and equipment. The NEC is updated every 3 years to reflect the latest technological advances and safety practices. It is important for electricians and electrical engineers to be familiar with the NEC and to follow its guidelines when designing and installing electrical systems. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, motor control, lighting, and special occupancies. It also includes specific requirements for different types of equipment and installations. The NEC is organized into chapters, articles, and sections, which makes it easy to find information on specific topics. The NEC is enforced by local and state authorities who inspect electrical installations to ensure that they comply with the code. Failure to comply with the NEC can result in fines, penalties, and even legal action. Therefore, it is essential for electricians and electrical engineers to stay up to date with the latest version of the NEC and to follow its guidelines when designing and installing electrical systems. Understanding the NEC is crucial for anyone working in the electrical field. It provides the necessary guidelines and standards to ensure the safety and reliability of electrical installations. The NEC is a living document that is constantly evolving to reflect the latest technological advances and safety practices. By staying up to date with the NEC, electricians and electrical engineers can ensure that they are providing the safest and most reliable electrical services possible. Master the NEC and be successful in your job. Time management is also critical when taking the master's exam. The exam is typically timed, so you need to be able to answer questions quickly and accurately. Familiarize yourself with the exam format and practice completing questions within the time limit. Start by reviewing the exam blueprint to understand the topics that will be covered. Then, create a study schedule that allocates sufficient time for each topic. When studying, focus on understanding the underlying concepts rather than just memorizing facts. Practice applying the concepts by solving problems and working through examples. Use flashcards to help memorize key terms and formulas. When taking practice exams, simulate the actual exam conditions as closely as possible. This means timing yourself and avoiding distractions. Review your answers to identify areas where you need to improve. On the day of the exam, arrive early and take some time to relax and focus. Read each question carefully and make sure you understand what is being asked. If you are unsure of an answer, eliminate any obviously wrong choices and then make your best guess. Don't spend too much time on any one question. If you are stuck, move on and come back to it later if you have time. Maintain concentration throughout the exam. Avoid distractions and stay focused on the task at hand. Remember to breathe and relax. If you start to feel overwhelmed, take a few deep breaths and try to clear your mind. Manage your time effectively. Keep track of the time and make sure you're on pace to complete all the questions. If you are running out of time, prioritize the questions that you know best. The master's exam is demanding, but with proper preparation and time management, you can increase your chances of success. Experience as a licensed journeyman electrician can be very helpful in preparing for the master's exam. As a journeyman electrician, you have gained practical experience in the field, which can give you a deeper understanding of electrical concepts and applications. You have also had the opportunity to work on a variety of electrical projects, which can help you develop your problem-solving skills. When studying for the master's exam, draw on your experience as a journeyman electrician. Think about the projects you have worked on and how the electrical concepts you are studying apply to those projects. This can help you better understand the material and remember it more easily. Also, consider seeking out opportunities to gain additional experience in areas where you are less familiar. For example, if you have limited experience with motor control, try to get involved in projects that involve motor control systems. This will help you broaden your knowledge and skills and prepare you for the exam. Supervising and managing electrical work can also be a valuable experience for preparing for the master's exam. As a supervisor or manager, you are responsible for overseeing the work of other electricians and ensuring that it is done safely and correctly. This requires a thorough understanding of electrical codes and standards, as well as the ability to communicate effectively and solve problems. When studying for the master's exam, draw on your experience as a supervisor or manager. Think about the challenges you have faced and how you have overcome them. This can help you develop your critical thinking skills and prepare you for the exam. Also, consider seeking out opportunities to gain additional experience in areas where you are less familiar. For example, if you have limited experience with project management, try to get involved in projects that involve project management responsibilities. This will help you broaden your knowledge and skills and prepare you for the exam. Teaching or instructing electrical subjects can also be a valuable experience for preparing for the master's exam. As an educator, you are responsible for explaining electrical concepts to students and helping them understand how to apply those concepts in practical situations. This requires a deep understanding of electrical theory and a strong ability to communicate effectively. When studying for the master's exam, draw on your experience as an educator. Think about the concepts that you have taught and how you have explained them to students. This can help you better understand the material and remember it more easily. Also, consider seeking out opportunities to gain additional experience in areas where you are less familiar. For example, if you have limited experience with curriculum development, try to get involved in projects that involve curriculum development responsibilities. This will help you broaden your knowledge and skills and prepare you for the exam. Preparing for the master's exam requires dedication and hard work. However, by following these tips and drawing on your experience in the electrical field, you can increase your chances of success. Stay focused, manage your time effectively, and never give up on your goal. With the right preparation and mindset, you can achieve your dream of becoming a master electrician. Remember, the master's exam is a challenging but achievable goal. With proper preparation and dedication, you can increase your chances of success. The exam covers a wide range of electrical topics, so it's important to have a comprehensive understanding of electrical theory and applications. Don't be discouraged if you don't pass the exam on your first attempt. Many candidates take the exam multiple times before passing. Just keep studying and practicing, and you will eventually achieve your goal.